Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Gerard, Debreu 1960 essay, Topological Methods in Cardinal Utility Theory, represents a watershed moment in the mathematical formalization of economic thought, published within the prestigious volume, Mathematical Methods, in the Social Sciences. The work stands as a monument to the power of abstraction and the pursuit of axiomatic purity. It demonstrates, with formidable elegance, how the seemingly intuitive notions of consumer preference and utility intensity can be derived from a sparse set of deep mathematical postulates. This essay will undertake a direct and systematic evaluation of the internal claims, logical mechanisms, and conceptual frameworks presented by Debreu. Proceeding section by section through his argument, the analysis seeks to illuminate the precise nature of his contribution, assessing the coherence and implications of each step in his construction, from the foundational definition of the commodity space to the ultimate derivation of a cardinal utility function unique up to a positive affine transformation. It is an exploration of a perfected intellectual architecture, a quiet revolution conducted in the language of sets and spaces. Section 1. The establishment of the primitive concepts and topological domain. Debreu commences his argument by establishing the primitive concepts with a deliberate and profound generality. The foundation of his entire edifice is the set of commodities, which he denotes as the set capital X. The critical claim made here is that this set capital X is a connected topological space. This initial postulation is of immense consequence. By defining the commodity space topologically, Debreu immediately lifts the analysis from the finite, discrete world of classical examples into a continuum. This move accommodates commodities that are infinitely divisible and allows for the application of powerful theorems from point-set topology. The assumption of connectedness is particularly insightful. It formally asserts that the commodity space is a single, unbroken whole, a space without any gaps or partitions. This is a mathematical idealization of the economic idea that one can move from any bundle of goods to any other through a series of small, incremental changes. The second primitive concept is a complete preordering on the set capital X, represented by the relation is weakly preferred to. This preordering satisfies the standard axioms of reflexivity, completeness, and transitivity. Debreu's claim here is that these two elements, a connected topological space and a complete preordering, form the sufficient bedrock for the initial stage of his inquiry. The evaluation of this claim is positive. The framework is both parsimonious and powerful. It strips the economic problem down to its most essential mathematical structure, freeing the subsequent analysis from any dependence on the specific nature of the goods themselves or the dimensionality of the commodity space. The argument's strength lies in what it admits. There are no assumptions about convexity, differentiability, or algebraic structure at this stage. The entire weight of the initial problem rests on the topological properties of the space and the ordering of its points. Section 2. The postulate of continuity and ordinal representation. Building upon the established foundation, Debreu introduces his crucial continuity axiom. The claim here is that for any element X within the commodity space capital X, the set of all elements at least as good as X and the set of all elements no better than X are both closed sets in the topology of capital X. This is a subtle and deeply consequential assertion. It provides the essential link between the preference ordering, which is an algebraic concept, and the topological structure of the commodity space. The claim's effect is to ensure that preferences behave smoothly across the space. There are no sudden, jarring reversals of preference for points that are infinitesimally close to one another. The evaluation of this postulate reveals it as the keystone for the first major result of the paper. Debreu demonstrates that a connected topological space endowed with a complete preordering that satisfies this continuity axiom guarantees the existence of a continuous real-valued function, let us call it the function u, that represents the preordering. This representation means that an element x is weakly preferred to an element y if and only if the utility value of x is greater than or equal to the utility value of y. The existence of such a continuous ordinal utility function was a known result, yet Debreu's proof is a model of mathematical elegance and generality. His method, relying purely on topological arguments concerning the ordered structure of the real line and the properties of connected spaces, provides a more direct and fundamental proof than earlier constructions, which often required more restrictive assumptions. The claim's a priori justification is its intuitive appeal, a formalization of the idea that small changes in consumption bundles should lead to small changes in satisfaction. Its a posteriori justification is its mathematical fertility. It unlocks the door to representing abstract preferences with the familiar and tractable tool of a continuous function. The internal logic is impeccable, proceeding from the axioms to the conclusion with deductive certainty. Section 3. The construction. For cardinal measurement, via a product space, the true novelty and ambition of Debreu's paper become manifest in its third major conceptual movement, the direct confrontation with cardinality. To achieve this, Debreu makes a brilliant and abstract leap. He claims that the problem of cardinal utility, which concerns the intensity of preference, can be modelled by constructing a new space and defining a new preference relation upon it. He considers the Cartesian product of the commodity space with itself, the set of all ordered pairs of the form open parenthesis x, y close parenthesis, where both x and y are elements of the original commodity space capital X. An element of this product space represents a transition or a difference from commodity bundle y to commodity bundle x. The central claim of this section is that a rational agent can compare these transitions. He postulates the existence of a second complete preordering, this time on the product space capital X times capital X. This new preordering compares the preference difference between x and y to the preference difference between z and w, stating that the pair open parenthesis x, y close parenthesis is weakly preferred to the pair open parenthesis z, w close parenthesis, is a formal way of asserting that the gain in satisfaction from moving from y to x is at least as great as the gain from moving from w to z. The evaluation of this conceptual step is that it is a profound and powerful abstraction. It successfully translates the informal, psychological notion of strength of preference into a rigorous, formal mathematical structure. The internal logic is consistent. If one accepts the primitive ability of an agent to order commodity bundles, it is a plausible, albeit significant, next step to accept the ability to order the differences between them. This construction, however, comes with its own intellectual price. The cognitive burden on the idealized, economic agent is substantially increased. The agent must now perform sophisticated comparisons on a much larger and more abstract space. Debreu acknowledges the abstract nature of this step, but his purpose is a demonstration of logical possibility, and on that front, the claim is entirely successful. The mechanism elegantly reframes the problem of cardinality into a problem of ordinal representation on a more complex domain. Section 4. The independence axiom and the emergence of an additive structure having constructed the product space and the preference ordering upon it. Debreu introduces the final, decisive axiom needed to secure a cardinal representation. This postulate is an independence condition, sometimes referred to as a Thomson condition or a cancellation axiom. The axiom states that for any three elements x, y, and z in the commodity space capital X, the preference relation between the pair open parenthesis x, y close parenthesis and the pair open parenthesis y prime, x prime close parenthesis is the same as the preference relation between the pair open parenthesis x, z close parenthesis and the pair open parenthesis y prime, z prime close parenthesis for any other elements x prime, y prime, and z prime, provided that the move from y to z is judged equivalent to the move from z prime to y prime. A more direct formulation asserts that if the preference interval from x to y is equivalent to that from a to b, and the interval from y to z is equivalent to that from b to c, then the interval from x to z must be equivalent to that from a to c. This is a statement about the additivity of adjacent preference intervals. Debreu's central claim in this part of the paper is that this independence axiom, when combined with the continuity assumptions on the product space, is the sufficient condition to guarantee the existence of a continuous real-valued function, let us call it f, defined on the product space X times X, which both represents the preference ordering on transitions and possesses an additive structure. This additive structure means that the function f of the pair open parenthesis x, z close parenthesis is equal to the function f of the pair open in parenthesis x, y close parenthesis plus the function f of the pair open parenthesis y, z close parenthesis for all x, y, and z in the commodity space. The evaluation of this claim is that it constitutes the technical and conceptual heart of the paper. The independence axiom is the linchpin that forces the representation to be more than merely ordinal. It imposes a rigid, consistent structure on how preference differences are related, a structure that mirrors the properties of addition. From this additive function f on the product space, it is a straightforward step to define the cardinal utility function u on the original space X. One simply fixes a reference point, say x subscript 0, and defines the utility at any point x as the value of the function f applied to the pair open parenthesis x, x subscript 0 close parenthesis. The resulting function u satisfies the relationship that the function f applied to the pair open parenthesis x, y close parenthesis equals the utility of x minus the utility of y. The argument is a tour de force of axiomatic deduction, demonstrating with absolute clarity how a specific, logically stated behavioral postulate translates directly into a specific mathematical structure for the utility function. Section 5. The assertion of uniqueness and the theoretical yield. In the concluding phase of his argument, Debreu addresses the uniqueness of the cardinal utility function he has derived. The claim is that the function u is unique up to a positive affine transformation. This means that if another function, let us call it v, also satisfies all the preceding axioms and represents the same preference structure, then it must be the case that the function v is equal to a positive constant alpha multiplied by the function u, plus another constant beta. The value of alpha must be positive to preserve the ordering of preferences. This is the mathematical hallmark of a cardinal scale. It is identical to the uniqueness properties of temperature scales like Celsius and Fahrenheit, where the 0 point and the unit of measurement are arbitrary, but the ratios of differences are preserved. An evaluation of this claim shows it to be a direct and necessary consequence of the additive structure derived in the previous section. Any function that preserves the additive property that the representation of the interval from x to z is the sum of the representations for the intervals from x to y and y to z must have this linear relationship with any other such function. Debreu's work here solidifies the meaning of his result. He has provided a complete axiomatic system, beginning with topological primitives and plausible behavioral postulates, that logically culminates in a numerical representation of preference that is cardinal in this precise and well-defined sense. The overall theoretical yield, as presented by Debreu, is immense. He has shown that cardinal utility, a concept that had fallen into some disrepute due to its perceived reliance on untestable psychological introspection, could be placed on a formal footing just as rigorous as that of ordinal utility. The work provides a definitive answer to the question of what, precisely, one must assume about behavior to justify the use of a cardinal utility function in economic models. The entire edifice, a testament to axiomatic purity, achieves a result of profound economic significance, albeit one that resides at a considerable distance from direct empirical verification. The achievement is one of demonstrating logical coherence. It is a blueprint for what a theory of cardinal utility must look like if it is to meet the highest standards of mathematical rigor. Conclusion. In summary, Gerard Debreu's topological methods in cardinal utility theory is a masterwork of formal economic analysis whose internal claims withstand the most exacting scrutiny. Each stage of the argument builds upon the last with deductive precision. The initial claim of a connected topological commodity space provides a general and powerful domain for the analysis. The subsequent claim that a continuity axiom on this space is sufficient for an ordinal utility representation is demonstrated with exceptional elegance. The paper's most original contribution, the claim that cardinality can be captured through a preference ordering on a product space, successfully translates an elusive psychological concept into a tractable mathematical one. Finally, the claim that an independence axiom on this product space logically necessitates an additive, and therefore cardinal, utility representation unique up to a positive affine transformation is the crowning achievement of the work. The evaluation of Debreu's paper reveals that its primary significance is methodological. It is less about asserting that all economic agents actually behave according to these axioms, and more about demonstrating the logical architecture required for the concept of cardinal utility to be coherent. The work established a new benchmark for rigor in economic theory, showcasing the extraordinary power of topological methods to resolve foundational questions. It transformed a contentious philosophical debate into a settled mathematical theorem, leaving a legacy of clarity, precision, and intellectual beauty that continues to inform the frontiers of economic theory.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.